Yeah, so hello everyone. I'm sorry for the delay, just because some rooms are not friendly to Max. So I have to rushly convert the presentation to another format. Hopefully it's working good now. So just to explain why I'm talking in English, because the organizers asked me to pay respect to our international speakers. That's great that they're here. We should be very thankful to have them here. And since I've done this presentation a couple of times in English and I'm fine with that, so I will do that in English. If you have any questions and you feel that maybe you're like, I don't know, scared talking in English or whatever, you can come later to me and ask in Russian. That's fine, I'll reply in Russian to you. So, but here I will be talking English, and I'm also would like to ask like a couple of excuses. So one is about the delay, and the other one is actually about the presentation format because I had to convert it to another dimension. So it's a little bit Russian there, but hopefully it will be like readable fine. So let's start. Debug C++ without running. What the talk is actually about? It's not about the debugging first. It's more about understanding the code before you even compile or run a preprocessor on it. That's what I call here the debugging the code. So it's kind of trying to get the meaning of your code while you're looking at it in your editor, in your IDE, whatever. And this is not a talk about actually JetBrains tools. While I'm working JetBrains as a product marketing manager for C++ tools, and I was a C++ developer for 8 years in various embedded networking systems. Here we'll be talking about the whole ecosystem. So we have lots of tools in the ecosystem, and I will be talking about what are they actually capable of. So I will be definitely showing our tools because they are a part of the ecosystems. But if you would like to learn something particular about our tools, we have a booth out there in the hall. So you're all very welcome to come to our booth and ask any questions you have. So this is kind of agenda which I'm going to cover. So first of all, I would talk about like why this talk actually happens. So what is the tricky part of the C++? Why we need to unveil these abstractions in some tricky way, and why the classical solution doesn't help, and what we actually have, what can help. So yeah, time for a quote. I like this quote very much. I use it every talk. Hopefully Björn is fine with that. So he has a side actually where he has this kind of subside where he talks that he really says that. So he really says that quote, but there is an explanation to this quote which is much more important. So, and the story behind this quote is actually that, as Björn says, this is true for all powerful languages, because while protecting us from dangers, they allow us to run into more harder issues because we just don't see them, because we're using some harder abstractions, and so we're running into harder issues with them. So that's why this quote actually happened. And to start with, I would like to share some statistics we collected. So I will be using two sources of statistics. One is our developer ecosystem survey, which we currently run every year. So it's done by JetBrains, but it's not branded by JetBrains, so we run it as some like more or less independent survey. How could be the independent survey run by JetBrains? But anyway, so we did it twice already. So the third one is coming in the end of the year. And the first time we collected like less than 2,000 of replies from C++ developers. But for the second time, it was like more than 4,000. And that's quite a lot, actually. To compare, I will be showing later results from C++ Foundation survey, which was run like by ISO, CPP, and the committee, and they collected 3,500. So it's actually a little bit less. But the results are very similar, so it actually means that they are true. And the results are that most of the people are still on C++ 11 and C++ 14. So the blue chart is from 2017, and the green chart is from 2018, so the beginning of this year. And so the people are still on C++ 11, C++ 14, while we have committed for C++ 17. We're nearly freezing the C++ 20. Like the next week, there will be the committee meeting in San Diego, and the final actually C++ 20 will be ready there, and we're still using some older standards, and there are reasons for that. And from the C++ Foundation, they got nearly the same charts. So most of the people are prohibited to use modern standards And by modern here, I mean like C++ 17 is not widely used, and even C++ 14 is not the most popular case for the people. So they're still on C++ 11. And there are some reasons, because there are some legacy code that, of course, you can transform to the new standards quickly, and there are tons of legacy code in C++. But there are also reasons that C++ is actually quite hard. And that's just true, because if you come, for example, to a game developer and say, like, I would like a game quickly, what they usually reply, we take Unity, put all our files into one folder, and get a game. That's the way to go. If you want something smarter, if you want something more beautiful, something more powerful, if we talk about AAA games, we're coming to really complicated custom C++ engines, to the Unreal Engine, which is usually freaking lots of people, lots of game developers, when they realize they have to implement something in C++ to use Unreal Engine. That's like not very easy. Embedded developers are mostly still on C, slowly, really slowly moving to C++, still implementing lots of things with struct, with like function pointers, trying to emulate some classes. I actually did it myself. I worked 5 years in embedded development. I was doing this like freaky classes through structs with function pointers. But like there is some movement to C++ in the embedded world nowadays as well, which is kind of good. And talking about C++ difficulties, let's try to see some examples and understand why actually it's not that easy. So this is a very simple example, a very short piece of code. And there is a story behind this piece of code. Actually, this code was generated by our QA engineer in CLion team. And she came out with this piece of code saying that like she was testing some feature and the feature was actually broken on this piece of code. So she created an issue, she pinged the responsible developer. The developer looked at the code, said like, yeah, there is a bug, but what's this code is actually doing? What's the meaning of this piece of code? And she said like, I actually know, I just was playing with the language features, and in the end, I came with this piece of code, which is, you can compile it, it's fine, but does it have any sense? So does it mean something to you? So we've tried to play with it a little bit, so we put it to Compile Explorer. So didn't see actually anything interesting inside, so just like, yeah, okay, some proper assembler generated. Then we tried to simplify it. So there was some variable template. We just, first of all, used the different syntax to look at like maybe our more easy. Then we just removed the variable template, and then we removed the cast because we don't know it, and we don't need it. So, and what is left actually return 42. That's all. All this code, what is actually doing is just returning 42. That's the whole meaning of this piece of code, and that's like, if we look at the original example, so it looks like some complicated piece of templated code. And all that is actually doing is just returning 42. So the problem with C++ is that you can write actually a very complicated piece of code, which after some simplification, you find out that it's a very simple piece of code, and you maybe don't need half of the code you have there. And you can easily into these issues. So that's not that you're just trying to create a very hard piece of code, and that's why you're coming up with such examples, but just if you're using modern language, you're doing that because like, yeah, that's the usual way to do some things, and you use these usual ways, and then you come up with such examples. A little bit creepy world of macros. So as Björn said at CPPCon this year, so that he really regrets we had them. I do too, but we still have them. That's our reality. We have to deal with them. And if you look at the example, the problem is that I have some macro definition, I have some txt file, and with the help of this macro and with the help of this txt file, I somehow generate the enum values using the preprocessor. And so after the X macro is undefined, I have no traces of what was happening there. So I don't know what actually it was doing because it's undefined, so it doesn't exist anymore. And this file is located somewhere, I don't know what is there, and it's not even a C++ code, it's just text. And out of these two things, I generated the proper code, which is a problem because while looking at the code with this foo function, you don't know what are the values of this enum. You have to somehow create a proper case, like switch case operator. You have to know all the values. It's good when you have like some tool that could generate all the cases for you. That's fine. Nowadays, quite many tools can do that for you. But in the just a text editor, you're looking at that and you're trying to guess what are the real values and what you should use in this switch case operator. And it's a complicated issue. It's a complicated problem here. Given a little bit more of a macros. So I have a know something about the context or whatever. It's just a text substitution. And you call this macro a couple of times and you get a class with some members and they're doing something. And while looking at this class def usage, you have to guess what actually is happening behind it. What is the class that is created there? You have to go to this macro definition, trying to look for it, and it could consist of several macros calling one each other, and somewhere in the middle of this path, you're feeling a little bit freaked out. There is another example here talking about the context and the preprocessor thing. So here is the example. If you look at the right part in the test function, at the last line, actually there is either an expression or a template. And it depends on the magic value on the left. So because in the first case you get abstract and that's fine, that's a template. And in the second case you get just an integer, so it's just an expression there. And so while looking at the right part, if you don't have the left part in the same file or it's somewhere in the library, if something like that happens to you, you can't even guess what the code is actually doing, not what this particular entity is, like is it a class or is it a struct or whatever, but you even don't know what is going on there. So what happens? So a little bit more complicated example of what's coming in our bright C++ future is of course the metaclasses, because with the metaclass you have the piece of code on the top right, then you have some metaclass definitions somewhere, probably in the library, and you get a piece of code on the bottom right. So you actually look at the code on the top right corner, and you have to understand that you will get some extra members and you have some extra smartness in this class that will be like coming from the meta class. And while looking at the code at the particular like timestamp while you're doing some coding, you need to have some way to understand what will be actually there behind this abstraction. And the meta class is a very strong abstraction in this sense because it hides a lot. And I would say that actually there is like abstraction that is in our language for many years, and some people even do not realize that it's a problem because we can overload operators. That means while looking at the single plus sign, you don't know what it's actually doing. Maybe it's doing a minus, or it's calling some crappy function, or it's doing something else. You never know. Actually, in this nice example, in the fraction example, in the output line, it uses half of the operators are from like kind of default standard library, and half of them are overloaded from my fraction class. And they look the same, and that's an issue. With the function overloads, actually function overload is not that complicated. So it's just the set of rules. You have to go through it and you get the proper candidate set, then you filter it, then you get the proper load. Everything is fine, but like this code is printing 2 and 2. What we all are doing here, trying to solve this nice puzzle, trying to check all the overloads, trying to find out which overload fits, what are the restrictions. And we have to do that every time we look at some function because maybe it's overloaded. And there is actually more complexity in the language, like coming with the context per, coming with the injected code, with all the reflection and meta classes stuff. And I would say that, like actually, yeah, so the classical solution would be just to like try to debug the code somehow, like to put some frames or just to call the regular debugger or call for the static or dynamic analysis. The issue is that, first of all, like I'm saying here that you have to guess the meaning of the language abstraction before you even compile the code, because maybe your code is not compilable on your local machine, so it's targeting some other machine. Maybe it's just a library, so you can't run it. Simply you have to like implement some test or application using this library. Yeah, and so maybe you just need to get some knowledge of the code base before even like running or compiling this code base. So you're just trying to collect some knowledge to understand something about this code. So yeah, the classical loop doesn't work many of the times. And actually, this talk is started with the Herb's talk at CPPCon more than a year ago. When he was, the talk was called First on Generative C++. You can find it on YouTube. It's a very good talk, talking about which language abstractions do we currently have. So he's presenting metaclasses there, and he's talking in the first part of the talk about all the language abstractions we have. And he says that abstractions are hiders, and to get the meaning of the abstraction, you actually need a tool support. And the third that he actually told there is that the good abstractions need to be toolable. And that's a very good point, because while creating a language feature, I think we should think about the toolability of this language feature. And hopefully this is kind of process that we try to build in the committee right now. We have in the tool and evolution group, which is to some extent for that particular reason. So just to check that the abstraction is that we're trying to introduce into the language is toolable from the points of the text editors, some smart text editors, some IDEs, some compilers, some static and dynamic analysis tools, some package managers, so they can deal with some things. So yeah, and the good example of this kind of a discussion is the current discussion around the modulus, which is actually, it covers many people. So many people are involved in this discussion, and many people are from the tooling side are currently worried about if the modulus will be toolable enough. So if they can implement them properly so that you can like benefit from this abstraction in your tool. Because the thing is that if the abstraction is not toolable enough, how big are the chances that the developers will be using it, or they are still stuck with C++11? Because if the abstraction is a real hider, if it's complicated, many people will be trying to avoid it, even if it could bring some benefits, but there is some cost also. And yeah, actually that was the slide from the Herb's talk, which I treat as a nice feature list for all the tooling, for all the IDs at least. And actually all this talk started from this slide particular. So let's see actually how the actual tooling can help. So what we can do in terms of the tooling. So we'll start with the macro debugging and understanding the preprocessor. And the goal will be to understand the substitution without running the preprocessor before it actually happens. So because if you run, yeah, you can get some output from the compiler, you can call these directives only, and you can see the whole stack. But let's try and do that before the preprocessor, which could take time, which doesn't happen all the time while you're just typing the code. So just what is happening on the previous step. So, and yeah, the first thing that we have is the ability to get the final replacement for the macro. This is the screenshot from CLion, and Visual Studio, the latest version, also can do that. So they both can just show you some window, like in the quick documentation pop-up, which shows the final replacement. So you can see at the bottom of this window that there is just a replacement, and so you can like go to some macro usage and just try to see what will be the final replacement when everything is substituted. Another example is, what if I would like to debug a macro in the way I regularly debug the application? So what if I would like to substitute just the next step and see what happens? Because if you just get the boost macro and try to see the final replacement, you'll see like a very big window, because the boost macros are really huge. Like try just to, in Visual Studio and CLion, just try to call the final replacement for boost test macro, for example. It's like 10 or 12 lines long. And so it gets just the whole screen. So I would like, in some cases, just to debug it, like to go through the macro step by step. That's why in ReSharper C++, the guys implemented this ability to substitute next step. So you can go through the macro step by step. And you can also substitute all the steps. So there is like a principal difference when you just call the, like, for example, this documentation pop-up with a final replacement. Nothing changes your code. So you just get a fresh look on what's inside and go. Here you can just substitute and maybe stop at some point and try to think it's that's correct or not, and then maybe change something at this point and then proceed. So that's a way when you're actually changing the code. It looks very similar, you know, to debugging when you're trying to set some values during the debug, which is a like great feature in the modern debuggers. And kind of a practical example is trying to substitute boost pp repeat. For example, you can go step by step to the left, or just substitute the final replacement, and then you get this line in the end. So this actually has some practical example, especially with these macros like boost. But like, be careful when doing that, and that's what we always have to think about while working with interesting macros, is that when substituting something in the like real piece of code, the context might be affected. So in this example, I actually have some new var macro, which is using the line macro. So just the which just returns the number of line in the code where this macro is used. And if I substitute the second macro, so no, it was not the line, it was the counter. Yeah, sorry. So the counter just returns the next next counter here. So when I substituted the second new var usage, it gets me like the variable v1, but now the counter in the third line actually gets the value 1 as well, because it's like 0, 1. So, and now the tool actually is like putting these red squiggles under the second usage, just because it actually sees that there is the duplicated definition used. So yeah, and this you have to think about while substituting something like some macros in a real piece of code, because it might affect one each other, like with all this line and counter macros. And this is actually the case, a very popular case in Unreal Engine, for example. They have this uClass, uProperty macros, which is used to emulate reflection, which we still doesn't have in the language, but all the game devs, they need the reflection in the language. And they try to work around it as much as they can. Unreal Engine does that using the macros, which is probably not the best solution, but that's the solution that works for them. And so every class and every function in the Unreal Engine, every like reasonable class and function, they actually have this uClass, uProperty macros. And this uClass macro, for example, it uses the line counter. And if you go to the top level of your file and try to type something, then the line changes, and you need actually to rebuild your project, or at least to call the Unreal Engine header rebuild tool. Otherwise, everything is just in the red squiggles in your IDE and nothing works, and they're just a nightmare. And to rebuild a project in Unreal Engine, it really takes time. So with this macro, you always have to be careful, really, because it can affect your workflow. Another thing that you have to think about carefully when thinking and working with such abstractions as macro is that you really have to take into consideration all the usages, and even the modern tooling can do that in some cases for you. This is an example which doesn't work in all major IDEs, because if you go to the func macro declaration and try to navigate from the func somewhere, you will get the two options, like the first and the second, but there is also one in the bottom, the third option. There is no IDE on the market that can show you the third option, because no one actually goes that further. But you have to see that, because that's also a proper definition. Yeah, so that's how it looks like. That's a screenshot from Eclipse I get. So it nicely finds all the usages, but not this one. There is the same way, like you try to understand the type, and like there is a first solution is trying to call something that will show you the infer type, because most of the IDEs, they work with the AST, so they have the type and they can actually show it to you. So all the merger tools on the market usually can do that. Eclipse, Visual Studio, like CLion and ReSharper C++, they do that. They show you the actual infer type, like double in this case. There is also the same flow that you would like maybe to have is to debug the typedef in the same way as you debug the macro. So in ReSharper C++, there is an option to substitute the next typedef, or like substitute everything until the very end. And you can debug in the same way, so you can stop at any point and try to change something. And there is some practical example again from BoostMPL. So when you can try to debug the type, and if you just substitute all the steps, you just find the type which is in the very end. And that can be useful if you would like to understand what is the real type you're actually, like what is the real variable and the real type of this variable you're actually gonna use. And this is actually quite simple because, again, like all the smart tools like IDEs, they build the AST. So they can provide you with information. Every tool that is like using, for example, Clang AST also has this information. More complicated thing is actually instantiating the templates. So when I'm instantiating the templates, I would like actually to understand what I'm actually instantiating. So what is the original definition? And there can be ways to get some information about this abstraction. So most of the tools like Visual Studio or Eclipse, they can show you the signature of the actual template that was instantiated, and they also can show you some like comments added before this function signature, like there on the top. And this nice screenshot on the left is actually from the tool called cdevelop, which is an IDE built on top of Eclipse. There is some cool guys in the universities in Switzerland that do that, and Peter Zommerland that actually like push that forward. So I really like this kind of feature because they have they can build the chain. So this is just one window, but they can build the chain of the windows, and you can see how the templates were instantiated one by one. And so you can see the whole chain and like gets the arguments that in the top part of this window, and try to understand if the instantiation went actually correctly and how you expected it. The thing that we don't have, but the thing that I would really like to have is something about the context per evaluation, and also like proper instantiating the templates, so trying to debug this kind of example. So if you look at it carefully, so I have a test program, and it actually calls get value with two different arguments, and so it goes for different paths in the get value definition. And what I would like to get is actually when I navigate, for example, from one usage, I get the proper highlighting, which actually highlights the active branch, like in color, and inactive branch in gray. CoreHard had this feature long time ago. They actually removed it because they moved to Clang engine, which is a good and nice language engine, but it's not yet there for us to, like, I mean, the tool vendors to implement a proper and smart tooling on top of that. It's only capable of some like very useful, very quick, but tiny features, like some basic things like completion or highlighting maybe. But here, like the CoreHard in the past had this thing when you like instantiating the template, you actually navigate to your template from this instantiation, and the code is highlighted, and you get the code completion and the whole IntelliSense, like this particular thing was used in this template. Actually, since that's the PDF converted, I won't show you the demo, but I think you've seen that. That's in Visual Studio, in the latest release, they added what they call template IntelliSense. When you have a template, you can, in some UI in the Visual Studio, you can just write in the actual types you will be using to instantiate this template. So there could be just a list, there could be several types. And then it will provide you the completion, for example, based on this knowledge of these types. And that's very handy because while just implementing the template body, you more or less know which types you will be using to instantiate the template. In most cases, like, I don't think that we're just implementing the template and like feeling like, I don't know what I will be using it for. We usually do. So that means that we usually can provide some list of some like basic types, for example, which we'll be using to instantiate the template and during the instantiation, and probably that could help us to write the template body. Talking about the overloads. So the example that I had previously about the overloads operators, part of them overloaded in my friction class and part of them are just default. So it would be nice to distinguish them, but that's a real tough task because it's very performance heavy, because you have to analyze a lot. It's more or less solvable in CLion. We allowed you to, like, if you put a cursor on one operator, it will highlight all the operators like that, or you can find all the usages of the particular operator, like go to this fraction class, take this stream output operator and say find usages for me and look at all the usages. But it's very performance heavy task, so but you can't do that like for, I don't recommend you calling it for all the operators, but it's very handy when you would like just to understand, looking at some operator and thinking that probably it's overloaded in some classes in my hierarchy. Talking about the function overloads, as I said, the function overload is a very simple process. It's just a set of rules. Would be good if a tool can show me how it actually works while calculating this overload process. So it would be good to understand why this or that overload is actually selected in my particular place of code. What we have now in the tools is we usually have, if you go to the function call, you can see the set of parameters, and some tools actually try to highlight which set of parameters actually fits here as an overload set, which don't, and you can see for them. So in CLion we just showed the list. Visual Studio allows you just to scroll through the list. In like Eclipse showing you the whole function signature, ReSharper C++ showing the whole function signature and the documentation for this function, so you can try to guess why this function was used. But none of them are actually doing the thing like trying to explain you why this overload was selected. It would be really handy if I could get a real explanation in my tool saying like this was excluded because like the privacy doesn't match, or this was excluded because of the like delete or something, or just because some wrong arguments. So none of them actually show the explanation, but I think the tool vendors have to somehow think and work around that. Probably that's a kind of interesting task. Yeah, and there is also one very good thing is that actually when you debug in some overloads, if you change some function signature, not through the like reliable refactoring that updates all the usages for you, but just manually, at that time you just break the navigation completely because you can't navigate to like other places where this function is used, for example. And we just implemented as a prototype. It's not a production tool, but we played around it, trying to implement a prototype for similar functions when you just change the function signature, but then still try to navigate to some proper place where it could be. And so navigation to similar function can actually try and guess where you're trying to navigate for some history or for some like similarity of the function. So it's doable, it's possible. It's just the prototype, but maybe one day it will be like a production feature. And the last thing I would like just to briefly talk here is with all these abstractions, so sometimes you have to deal with all these includes and have to understand that your code is not like dead under the tons of includes you have and all the abstractions in them. So there is this very nice article that was published back in 2011 about the header hero tool, which we kind of re-implemented in ReSharper C++. But the article itself was about, so it was talking that for the lifetime of the project, while the number of lines increases, the number of included headers, so it also increases. And sometimes there is no proper reason for that. So just because the people are adding new and new includes to their code. And the compilation time increases as well, and there is a nightmare starting at some point there. You can try and fight with that through the precompiled headers. So when you can put a lot of information, compile it once, and then just use. But I've heard many times from people that that's not good. So we try not to relate a lot on precompiled headers because it doesn't solve the issue. It just hides it from you because it's just trying to increase the compilation time, but not like removing unnecessary includes. And of course, there are tools to analyze that. So the tool that we implemented in ReSharper C++ based on this article was the includes analyzer, which actually shows you all the files and how many lines they take and like how many lines was parsed and how many lines inclusively with all the includes were parsed, which is much more important. So you can sort, look at the like winners and try to deal with them. And there are actually tools that can help you with automatically dealing with such winners, such some optimizers. Like the most simple is unused include check, which is like it exists in many tools nowadays on the market when they just highlight you some include as unused and you can remove it. Some optimization. There is include what you use, a very famous tool from Google, which they claimed helped them to reduce the compilation time by 40%, which is great. Like the real project when you can reduce the compilation by that amount is really cool. And the includator, which is working in Eclipse, it's doing nearly the same job as include what you use. You just try to analyze and find all the unused includes and try to suggest you to remove some or change some includes to the forward declaration, which actually reduces the number of links between the files. Yeah, so and this is the number of links to the talks and some researches I was using in the talk. So if you're interested in some particular data, so you can like take a picture of the slide and find some links later. And thank you. So yeah, I think we have like 5 minutes for the questions still. So if you have some, you're very welcome. You can ask in Russian. If you're shy in English, I will translate our guests. Yeah. Okay, so everyone is shy. So then you can come just later to our booth to me and just ask something in person if you still have some questions. I will be happy to answer. There was a question maybe not related to the talk, but the question was about our plans for CLion tool, since I'm like from JetBrains talking about the tools. Like language is the top priority, and we're currently, like I was talking here a little bit, that we're participating in the committee meetings and trying to get the knowledge of what's happening there. So what is the state of the modulus, what's the state of the context for the most like tricky features in terms of the toolability for us, and we try to keep a track of that and to make sure that the features accepted to the standards are toolable. So that's the major activity we are doing. The second thing here in the direction of the language is the some ClangD based stuff we're implemented. So we have an experimental language engine based on Clang in addition to our own language engine, which is used for all the refactorings and cross navigation and whatever. So we also have like ClangD based tooling for currently just annotating the errors, but that means that like CLion currently deals nicely with all the modern features when they are implemented in Clang, just because we're taking the Clang master branch and merging it into our own branch. And like the next big direction is the remote development. So if you come to our booth, I can like show you how the current feature which will be released in the end of November called initial remote development support is working when you have your code, like you have your ID locally and your code is compiled and run on a remote machine. And the next big direction which we're gonna cover next year, and we've started already, is the embedded development. So we're gonna go to this market and we have to implement a lot. There's a huge fold of different features we have to do. Yeah, and there is always like a huge tracker, which you all, I guess, are coming from time to time. We have lots of things to fix there. So that's in general about the plans. Okay, yeah, that's it. Thank you.